you can watch it later if you don't understand. Okay, so for 2.2, I said a closed vector diagram is a diagram where you're gonna draw the vectors head to tail, and they they're gonna form a closed shape in a way. So once you see that when you connect the vectors, they form a closed shape, you know that the resultant vector has a value of 0. And by the way, you also, another thing, you have to draw your vector diagram on the Cartesian plane. So basically when they ask you whether something is a closed vector diagram, they're just asking what happens when you draw all these vectors on the Cartesian plane head to tail. Will you get a vector of 0? But since here we're talking about forces, sorry. Since we're talking about forces, all we have to do is look at the statement, because they say a heavy object is lifted using 2 ropes and 2 pulleys, as shown in the diagram below. So here they say the force A, force B, and the weight, which is the gravitational force, will not form a closed vector diagram. We don't have to go and draw it head to tail. We have to focus on the resultant vector, which has to be a 0. But since the object is being lifted, that means its motion is going up. And they don't tell you whether it's at a constant velocity or not. So you're gonna assume that it's not at a constant velocity because they did not state that it's at a constant velocity. So since it's not going up at a constant velocity, that means there's acceleration and the object has a mass, and that means the net force is not gonna be 0 because the object is accelerating at the end of the day as it's going up. So do you understand that? I think that's my reason for 2.2. I don't know whether you guys have a better explanation, or maybe I used too many words, but is that fine? I'm sorry. Do you guys understand me? Okay, so what I'm gonna do is put this here so you can just write in the chat. So basically what I'm saying is that the object is being lifted. So that means that this force plus this force is overpowering the weight. So that means your resultant force is not gonna be 0. That's basic. That's the gist of it. So do you understand that one better? Oh, okay. So now we're gonna go to 2.3, where they say calculate the vertical component of FA. I'm pretty sure you guys at this point you understand how to calculate the vertical components and horizontal components, right? So how about we do this? How about Kyle is gonna calculate the vertical component and Jason is gonna calculate the horizontal component, and you guys are gonna give me the answers. So I'm just gonna give you guys like till like 20 to 10 to do that, and then you're gonna give me the answers. Kyle, you can write it down or you can and give me answers in 2 decimal places. So can you guys do that for me? So guys, did you get your answers? I'm Jason, did you get your answer?
Yes, sir. I got that for 2.3.2. Like that was Kyle's answer. I got that. And then for 2.3.1, I got 249.67.
And the vertical component, I think you mix them up. Yeah, I can see your answers. You mix them up. You took the vertical component and made it the horizontal component, and the horizontal component, the vertical component.
Did I do that? Yeah.
Yeah, yeah.
Uh,
But don't worry, like it's just like you got the answers, but yeah, it is correct. So now we're gonna go to the next question where they say calculate the maximum weight that force A and force B will be able to lift from the ground and show all your calculations. Um, can I give you guys 10 minutes to try this? If you don't mind, like I'm gonna give you guys 10 minutes to like 10 to 9 to try this. And I'm also gonna try it on my side and see. 2.4.
What number is this?
Try 2.4.
Okay.
I know you tried it, Jason, but I don't know. I'm gonna try two, and then I'll give you the solution.
Okay. So was EP equals MGH like the completely wrong equation to use?
Um, E.
EP sir, equals MGH.
A. No, we shouldn't be including energy in this situation.
Okay, sir.
Yeah, because you don't have the height, and they don't want the height. EP is equal to MGH. Yeah,
So they say now
you found the
calculate the
height.
maximum weight.
Maximum weight,
Okay.
yes, not the maximum height.
Okay.
Uh, so I just want you guys to try it, and then I'll tell you what you were supposed to do if you get it wrong. But if you get it right, then I know that, like, at least I know that you know the stuff. Or I can say I know that you're ready for this test. Mm. So guys, I think that was enough time. What was the answer that you guys got? I'm sorry. Can you write your answers like in the chat box or something? Mhm. But Jason, did you try?
Said I didn't know how to start. I didn't.
Okay, um, so first thing we have to recognize what direction and what axis our weight is gonna be on. Because every time they're gonna say weight, um they mean the gravitational force. So in physics, we all know that the gravitational force is always going to be in this direction, pointing downwards. So that means if we want to find the weight, we have to find the y components of all these vectors. So that's the first thing we're gonna do. Since weight is on the y axis, and it has a 0 on the x-axis, we're just gonna find all the y components. After finding all the y components, since they want you to find the maximum weight, that means at this weight, your resultant force should be 0 or should be approaching 0. So do you understand that part? So when they say they want you to find the maximum weight, they want you to find the weight where the resultant force is nearly 0. But we're just going to conclude that it's equal to 0 because at the maximum weight, like that's why it, that's why it's near impossible to lift this object, and that's where our resultant force is going to be 0. So first thing we must do, since we have the vertical component of A, we're going to have to get the vertical component of B. So if you look at B, you're going to draw your triangle, and this is the adjacent side, and your vertical component is on the adjacent side, and your hypotenuse is 1440. So that means that in order to find the adjacent side, you're gonna have to use cosine to find your y and sine to find your x. So in order to find this, you're gonna say fby, that's gonna be equal to cosine of 10. And 440 cosine 10. And after finding your x, you found this, and here you already have this part. So all you have to do now is add them together to find the resultant of 0. So let me make space on this side. You're gonna say FAY plus FBY plus weight is equal to 0. And then now you're gonna substitute, you're gonna have so now you know that you're gonna take this weight to the other side and it's gonna become a negative. So you're gonna end up with you're gonna add these two. You're gonna have 118.12 plus 683.98. You're gonna end up with 2102.1 is equal to negative weight. And in order to change this weight to a positive, you multiply both sides by -1. So here it's going to change into a positive, and here it's going to change into a negative. So the maximum weight that the forces will be able to lift off the ground is -2102.1 newtons. So guys, I think there's one thing that you must realize, that when we're coming to physics, weight is in newtons, and we're not gonna use like kilograms or stuff like that. So do you guys understand this part, or do I need to explain on it further? Let me just have the chart here. So do you understand, or do I need to explain? Do I need to explain this more? I can't say that the resultant is
That's like
0.
that example that we had.
Oh yeah, sorry. You can try to explain.
Okay. Do you remember that the previous example where we had the object and the 56 degrees? I mean the 56 kilograms. Since it's hanging in the air now, and the police is above it, and the newtons and the degrees is above it, everything is above it. The resultant is 0, since the only forces that is acting on it really is the gravitational force and the normal force. So that's why it's 0.
Not really. When it's in the middle of the air, there's no normal force. The normal force needs a surface to exist. So I understand what you're saying, but let me just explain this. So when they say the maximum weight, right? That means this object has to be close to not moving. So it's not like the resultant is exactly zero. The resultant is actually approaching zero. But when coming to calculations, you have to state it as zero. I don't know if you understand this part. It's like when you're tired and you are close to passing out, but you keep on working, even though you know that you might pass out at some point. So it's the same thing here. It's like the resultant is approaching that point in which, okay, it's like these two ropes are approaching a point in which they will no longer be able to pull the weight, but they are still able to pull the weight. I think that's the best way to explain it. But when you're calculating, you're gonna have to conclude your resultant is zero. So I think that's all the time we have, because this meeting is gonna end soon. So I'll send you guys an explanation for 2.5, and then I'll send you in the form of a voice note in the WhatsApp group, and then it's all gonna be nice. So hope that you guys have enjoyed the rest of your day and the rest of your weekend. So I'll see you on Thursday, right?